Welcome to Study Loop.
So the complex given in this problem is Fe H2O6 2 plus, and since we have here 6 ligands, that means that it will be an octahedral complex. And for octahedral complex, we can have the d orbital splitting in two ways based on the strength of the field induced by the ligand. So if we just draw it in both ways, so if we consider it as a for the weak field ligand, and we draw here another one for strong field ligand. So how will electron occupy these two orbital splitting? So for that, first we have to identify the electronic configuration of Fe2 plus, which is argon and 3d6. So we have 6 electrons in the Fe2 plus d orbital. So in case of a weak field, what will happen? So in case of weak field, this energy gap between these orbitals will be comparatively low, and the electrons first will occupy one at a time in both the lower energy level orbitals and also the higher ones, and then they will pair up. So we have one more electron left. So that's how the orbital splitting in case of a weak field ligand for Fe2 plus will look like. And if the ligand is a strong field, what will happen in that case? This energy gap will be very high, and the electrons will occupy the lower energy level orbitals first by pairing, and then if more electrons left, they will go to the higher one. But since we have only 6 electrons and they are already occupied in these 3 lower energy level orbitals, so in case of strong field ligand, the orbital splitting diagram of our Fe2 plus will look like this. So from here we can clearly see that in case of weak field, we have 4 unpaired electrons, and in case of strong field, we don't have any unpaired electron. And since it is said that the complex is paramagnetic, we know that a complex being paramagnetic means it has at least one unpaired electron. So if a complex does not have any unpaired electron, then it is a diamagnetic compound or complex. And since there are more than one unpaired electrons, this one is paramagnetic. So from this discussion, we can say that the ligand here, H2O, is a weak field ligand.